Hi there everyone, welcome to this video where I'm going to go through the product rule. Now the product rule is a simple rule that we use to differentiate functions that are multiplied together. So let's look at these two here. Now the first one, part A, I reckon that's easy to do because we can multiply out the brackets first, get those expressions there, and then differentiate each term. So the derivative here would be 12x to the 11 minus 10x to the power of 9. Now if you look in the second one, that's a nightmare because x minus 1 to the power of 10, that's going to take you all day. Expanding that thing out. That's 10 lots of brackets there. So we've learned a way of doing that one there with the chain rule so we can differentiate that one. But then multiplying everything by x squared, it's a bit of a nightmare. So the rule today is how to differentiate functions when we can clearly see it's one function times by another one. Alright, so we know the answer to that first one, part A. Let's kind of assume, let's do the derivative of each. So let's call ux to the 10 and vx squared minus 1. Let's do the derivative of each of those, which is easy. Multiplying those two answers does not give us the correct answer for the derivative. So first thing we've got to realize here is, if you want to do the derivative of two functions times together, it is not just the derivative multiplied together. That ain't going to work. But if we multiply the derivative of the first by the second function, then add on the derivative of the second function multiplied by the first function, which gives me that. Now if we add those two answers together, you can see that we do get the correct answer. And that is the product rule. I'm not going to prove it here, but I think we'll leave that for another time. That is the product rule. dy dx, the derivative, is v times du dx. So the second function times by the derivative of the first plus u times dv dx. So that's the first function times the derivative of the second. And you're always given those formula on your formula sheet. So I'm just going to go through a few examples. You can see on the left here how that works. We do the derivative of each and we just kind of do this cross method where you say that times that plus that times that. If you set it out like this, you'll have no problems. Now just looking at this one here on the right, I think I'm going to simplify that because we do have some common factors here. X to the power of 9 is common. So one way we could do that is take out a common factor of x to the power of 9 also, and eventually we would get to this answer, which is the correct answer. Okay, let's look at the second one now that I said was going to be a real hard work, and let's use the product rule now. So we're going to say u is x squared, v is x minus 1 to the power of 10. Let's do the derivative of each of those. So du dx, 2x, easy. dv dx, going to use the chain rule. Okay, so number down the front, subtract 1 from the power, multiplied by the derivative of x minus 1, which is just 1, so there we go. Now we just do this cross thing. It's just that times that, plus that times that. And notice, because we're adding, it doesn't matter which order we do it in. Easy. So, that times that, plus, yeah, we've just changed the order. I like putting the 2x at the front, it's good. And then we go that times that. So 10x squared times x minus 1 to the power of 9. There we go. We do not want to multiply out here. There's 11 terms in this thing here. There's 10 terms in this thing here. Nightmare. But the common factors here. We've got 2x and x minus 1 to the power of 9. So they're the common factors. That times x minus 1 will give us the first term. So all of that there times by x minus 1 will give us that term. And all of this here times by 5x will give us this term here. Now this second bracket simplifies nicely to give that. Now you might be wondering, why do we have to go through all this process here? If I now want to find, for example, the question of when is the slope of this graph 0, which is a really good question to ask if we're talking about practicalities, then I can quickly see from here the values of x where that's true. 0, 1, and 1/6 are what we call the stationary values of this function. So it is actually really handy to go through this process here. Okay, so product rule we've been through. I'm going to show you one more chuff example. There's the formula. I'm just going to switch over to my iPad now. Okay, this is the example from page 50 on your notes that I've given you. Look at the first one. We've got a root x in there. So we've just used the same rule. Once again, we're using the chain rule to differentiate x to the power of a half to a half x to the minus a half. And we're using the chain rule again to differentiate 2x plus 1 to the power of 3. Okay, putting those together. Now notice they've got a little bit of shorthand, and this is the one that I like using as well. The derivative, dy dx, is u dash v plus v dash u, or u v dash. Okay, that's just a little simplification. So really the formal way of writing u dash would be du dx. And v dash here is actually dv dx. Okay? Putting it all together gives you that final answer there. Notice we haven't tried to simplify this, but we could keep going here. That's all right to leave it like this. And part B is very similar to the one that we've just seen on the PowerPoint, where you have to use the chain rule to do this second function here, and then putting it all together. I would go a little bit further here and take out the common factors. So here the common factor on each is 2x, and we've got x squared minus 2x cubed. Okay, so that times by x squared minus 2x will give us the first term, and all of this, so that gives us the first term, and all of this times by 2x minus 2 will give us the second term, won't it? Now inside that bracket there we might be able to do some collecting of like terms, which makes this nice. 2x, x squared minus 2x cubed outside, and in this bracket we've got x squared plus 4 lots of x squared. That's 5 lots of x squared. And we've also got negative 2x and then take off 4x. That's take off 6x. So you can see we do a little bit of simplifying there. And yes, some of you might say, well, x is common to that second bracket, so 2x squared minus 2x cubed, and then 5x minus 6. Again, that really helps us to identify the stationary points on this function here. So 0 would be one, 6 over 5 would be one from there, and from this one here, we could get 0 or 2 as a stationary value. In other words, a point where the derivative here is equal to 0. That's the product rule.